Alright, so I'm going to do a little tutorial for you for Lab 2 in case you're still having trouble with it. So the purpose of the lab is to get some hands-on experience to visualize how an algorithm executes and to see which of the steps are getting executed at what point. And so if we look at the exercise 2.4 question, and let's say we're looking at the first one where it says target step element is 1 and then the first column says step 1. So that means we're trying to look for target element 1, which is the first one in the list right here. And then we want to see how many times step 1 gets executed, which is the one up here. So there may or may not be any dependence depending on there may or may not be a dependency on the target step element. So let's just take a look at it here. So let's see. So the first step is get the target value, and actually, if you look at the algorithm, you can see that it's only going to get called one time because it does this step and then it goes on to the next one, and there's no loop that makes it go back to step 1 again. So it's pretty safe to say that all the values here are going to be 1. Because you see, if you're no matter what element here you're looking for, let's just actually step through this and say we're looking for 38. You see that step 1 gets called, and then you keep going, and it actually never comes back to it. So you can see there that it only gets called one time. So let's just complete this right here. And so this last one here might be a little tricky, but it's really just trying to ask you to generalize the pattern that you're observing. So we can see that for every element target that you're looking for, it's always going to be 1. So if we want to express that in terms of k, then you would still actually just put 1, because we know that no matter if you're looking for element 4 in the list, or if you're looking for the first one, you're always going to execute this step 1 time. So there is no dependency on the element in the list that you're looking for. It's always going to be 1. And step 2 is actually the same, because if you look at it here, it just gets called that 1 time, and then it falls through and it never gets called again. So it would be the same thing as step 1. But let's take a look at a different step. Let's take a look at step 5 and see how many times it gets called. So let's see. Let's start with step. We'll look for target element 1 in this case. Okay. So we're looking for this element, which is the target element 1, and keep track of step 5. So we're here. We've executed it 1 time, and we found it. And we go back to check to see if the statement is true, and then we exit out of the loop, and we're done with the program. So we can see here that step 5 gets called 1 time when we're looking for the first element. So okay, now let's look at the second element. So in this case it would be 80. So check the while loop. We execute step 5. We haven't found it yet, so we go to step 8. Go back to the while loop and check again if we found it. In this case we did find it, and we check the while loop again, and we're out of the while loop. So you can see here that we've called it 2 times. And if you actually repeat this over and over again for all the other elements, you should see the pattern start to become clear, in that you're executing step 5. The the number of steps you're executing for step 5 is the same as the actual target element you're looking for. So this will be 3, 4, 5, etc., and this will be 8. So then the question is, how do you express this in terms of k? And so if you looked at the homework notes, try to give you some hints on how to express this. So really, expressing this in terms of k is just a way to generalize the expression such that if you're looking for element 50 or 100, if you plug that into the expression, you would get your answer. And so we know that for the target element 1, the answer is going to be 1. And for element 2, the answer is 2. And for element 8, it's 8. So how do we express that in terms of k such that if we were to plug this element number into the expression, we would get the same answer here. So if we express it with k, then we would get our answer, because we can check that by saying, if we pretend this number here is actually k, so we put in a 1 for k right here, we would get 1. If we were testing element 6, we put 6 in for k, and you get 6, because that's actually the answer right there. And if you put in 3 for k, you would get 3, which is the right answer. So that's sort of how you express the answer in terms of k. And I'll leave it up to you to fill in the rest of the steps. So you're just going to want to step through the lab, and you'll keep track of how many times each of the steps are being executed, and you should soon be able to notice a pattern and then fill out the chart for 2.4. Then for 2.5, all you're doing is adding up all the expressions in this bottom row here for element k. You just add up everything there, and then you're going to come up with a formula. And so that will give you the formula for the total number of steps. And then you use that formula to basically plug in 100 into the formula, and that will give you your answer for 2.6. And then for step 8, for exercise 2.7, they want you to look at the average number of comparisons that you're going to perform. For the first one, it says for an 8-element list. So let's see, so that really deals with the answer you get for step 5, right? So how many comparisons are you going to do if the target element is in step 1? Element 1. So you would just do one comparison. If it was in element 2, then you would do 2 comparisons here, right? And then for element 3, you would do 3 comparisons. So the number of comparisons you're going to do is basically 1 plus 2 plus 3 plus 4 plus 5, 6, 8. And then you're going to divide that by the number of elements in the list, which is 8. And so that should give you an answer of 4.5. So you should be able to generalize this eventually and express that for an n-element list. But you can apply the same methodology for each of these questions over here as well. I hope this helped, but if it didn't help, feel free to send me an email or a question on discussion forum, and I'll be happy to help you out. All right, see you next time.